inshallah, we will study the last thing in the integration. It's not the last lesson, but every last thing. Last thing. What do I mean by last thing? Now you can, by taking this lesson, integration by parts, you will be able to integrate anything you want. Anything you want. By taking this lesson, you will be able to do any integration you face in your life. Bi-idhnillah. Okay? So, but we will still have some other lessons that are not related to the integration, but related to the unit itself. Okay? So, integration by parts. Integration by parts. As you can see here, this method is used to integrate the product of two functions. Product of two functions. See, for example, the first one. See this question. Let me just. Okay. If I want to integrate something like this, x is a function. The x itself is a function, and ex is another function. And also you can know that if we have, for example, integration for, let's just say 2x and ex squared. Okay, this is f dash of this, right? This thing I can use substitution, the previous lesson, not this lesson. But if I have two functions, and they are not differentiation of each other, or one of them is the differentiation of the other. Okay, I will need to use integration by parts. How can I do that? I will explain the first one. By explaining the first one, bi-idhnillah, it will be so clear. And we will discuss many other things after we finish doing the first one. Again, I would say, let u equal x. U equal x and dv equal ex dx. I want you to see that I divided my integration to two parts. This part I called it u, and this part I called it dv, and I have here integration. Okay, u dv. Okay, how can I do it? By using this rule. How? It will be u multiply v minus integration of v du, according to the rule. Okay, how did you know this rule? We proved this rule. There is a proving for it. I can show it to you, but I will not show it to you now. Okay? I will show it inshallah later, but I want you now to take this as a rule. See, my integration, I made it to be u, which is x, and dv, which is ex dx. Is that clear by now? The beginning is clear?
Yes.
Good. Right. Now, if you notice, I need u, it's with me. I need v, v is not with me. How can I find v? By integrating this. Okay, if I integrate both sides, integration of dv, what will it be? It will be v, right? Integration of dv. What is the integration of dx? It is x. What is the integration of dv? It is v. Okay, equal. Integration of EX. The integration of EX is EX itself. Okay? Don't put plus C. We don't need it for now. We don't need it for now. It's only V. Okay. So I found V, which is this. Now I have U, it's with me. I have V, it's with me. V again is with me. I still need du. How can I find du? Easy. Du equal, what is the differentiation of x? It's 1 dx. So my integration, I equal, according to the rule, u by v. What is u? I will multiply, just a minute. Let me just change the color. I can use this. Okay, multiply this by this. Okay, then this with this. What do you mean, teacher? What the hell are you doing? Okay, it will be u by v. It will be x ex. X ex. Okay, minus. Why minus? Because it's minus from the rule. It's minus from the rule itself. Integration. V. What is V? It is ex. du. What is du? This is it. It's dx. Oh, ya salam. Really nice. Now my integration, this one, has been converted to be like this. To be like this. And as you can see, this part, we don't have integration in it. And this can be integrated easily. Right? So the answer is going to be equal x ex minus, what is the integration of ex? Ex and plus c. If you want to make sure that your answer is correct, just differentiate this. If you get this, that means your answer is correct. And if you do that, it will be correct. You understand? Good. So as you can see, integration by parts is to convert my hard integration, because I don't have a rule. I don't have a rule to integrate x multiplied by ex. But I made many parts, 2 parts. One I called it u, and the other dv. One part of the integration I made it u, and the other part dv. Then I tried to find u, v, and du, and substitute it all in this rule. Substitute it all in this rule. Okay? I need you now to take a screenshot. So we can integration of x to the power of 3 ln x. As you can see, x to the power of 3 is a function, and ln x is also a function. It is also a function. Okay? So they are multiplied by each other. But x to the power of 3 is not differentiation of ln, or even it's not differentiation of part of ln. Yeah, means that the first function is not, the first function is not differentiation of the second. And even the second is not differentiation of the first. So directly I think of integration by part by dividing my integration to integration. I will say this is u and this is dv. This will be uv minus integration of v du according to the rule. Okay, I will say let u equal x to the power of 3 and dv equal ln x, and I meant to do it this way, and you will know one moment later that this substitution will not work. Why? I will tell you why. Now I will try to find du. Why I need du? Because I need it in my rule. But du is easy. It's 3x squared dx. Right? Also, I need v. Why v? Because I need it here and here in my rule. So how can I find v, by integrating both sides. Okay? By integrating both sides. Integration of dv is v equal integration of ln x. What is the integration of ln x? Do we have a rule? Do we have a rule for ln x? Is there any rule for that? Oh, shit. There is no. There is no. There is no rule, direct rule, I mean, or standard rule to find integration of ln x. That means my substitution was wrong. My substitution was wrong. I will get back. Okay, what will I do? I will do u equal ln x and dv equal x3 dx. Can I do that? Yes, I can. Yes, I can. I made the first thing with the dx as dv. And I made ln x as u. Why? Because I can differentiate ln x easily. What is the differentiation of ln x? It's 1 over x dx. Now, to find v, I need to integrate this side and this side. So it's going to be v equal x to the power of 4 over 4. Easy. Now, what will I do? I will apply the rule by multiplying this by this and this by this. Right? How? Integration. My integration is going to be uv means it's ln x multiplied by x4 over 4 minus, because the rule says minus, right? It says minus. Okay? So, minus integration. What is v? It is x4 over 4. Okay? du. What is du? This is it. It's 1 over x dx. It's really easy now. See what will happen? Equal. I will put in front at the beginning. It will be x4 ln x all to the power of 4 minus. I will put 1 over 4 outside the integration, and this x will be cancelled with this 4, so this will be 3, right? Are you with me? Integration
Yes.
of x3 dx. So my integration has been changed to really easy integration. See, it was x to the power of 3 ln x. It's really hard. Nothing harder than that. Nothing harder than that. But now, see, where did I get? Where I am now. The first part has no integration. It's just term. We just put it. And the other part is an integration, and the easiest integration you may have in your life. Right?
Yes. Yes.
Equal x to the power of 4, sorry. X to the power of 4. Okay, ln x over 4 minus 1 over 4, x4 over 4, because it's integration, right? Plus c. That's it. I can take 1 over 4 as a common, and x4 also as a common, to simplify more, 1 over 4. x4, open bracket, we still have ln x from the first term, minus 1 over 4 from the second term, plus See here, integration of ln x. As I said before, there is no rule for that. There is no rule for that. How can we do it? How can we do that? I would say, I might say, there is one here. Let this be u and this be v. Let u equals 1 and dv equals ln x dx. du equals 0.
ما بينفعش.
There is no. So my substitution again is wrong. I meant to do that. I know. You objected. Just wait, give me a break. Okay? Now, listen. I can say that u equal ln x. Why ln x? Because it's easy to be differentiated. Differentiation. While 1, I mean dv equals 1 dx. I can consider 1 here. I can put 1 in here. You understand? So now du equal 1 over x dx, right? Integration. What is the integration of dv? It's v. What is the integration of dx? It is x. Now it's ready. Now it is ready. This by this and this by this. Okay? So I equal ln x by x, ln x times x minus, why I'm doing that? According to the rule, right? But then integration of v, which is x, du, which is 1 over x dx. This x will be cancelled with this x. So my answer is going to be x ln x. It's better to write it this way. Ln, you let it at the end. It's better to be that way. Minus integration of 1. It is x plus c. Is that easy? Nothing easier than that. It is really easy. Equal x ln x minus 1 plus c. This question, I think we faced this question in the lesson of, you still remember, lesson of the substitution. You remember that? I will remind you. We said before that let you, now I'm doing it by using substitution, not parts. We said x plus 3, right? Therefore, x equal u minus 3. This is the lesson of yesterday. It is the lesson of yesterday. Okay. Now du equal dx. So my integration is going to be, what is x? This is x. It's u minus 3. Okay? U to the power of 3 because x plus 3 is u. du. Right? You remember this? It's from yesterday's lesson.
Yes.
You should remember. I'm asking, please answer. Okay, can I continue? Now, multiply out. It is u4 minus 3 u3 du equal u5 over 5 minus 3 u4 over 4, okay, equal take u as a common, take u as a common, u to the power of 4 is a common, okay, still have u over 5 minus 3 over 4, okay. Then substitute now u, it will be x plus 3 to the power of 4 bracket u which is x plus 3 over 5 minus 3 over 4 plus c. That is the answer. That is the answer. The answer would be like that. The answer is going to be like that. Okay? Now, what will happen? If I use, the problem is, I will write the answer in here up. I will write it up. I will write the answer that I got here. It is x plus 3 to the power of 4, okay, bracket x plus 3 over 5 minus 3 over 4, okay, plus c. I will leave it here while I will clean everything in here. Let's just see, will we get the same answer or not? I will say, let u be x and x plus 3 to the power of 3, just a minute, I'm sorry, dv, I mean, equal x plus 3 to the power of 3 dx. Are you with me?
Yes.
Okay. Now du equal dx, right? And to find v, I will integrate here and integrate here. V equal, what is the integration of x plus 3 all to the power of 3? This is linear expression. It is linear expression to the power of 4, to the power of 3, I mean. So it's easy. It's going to be x plus 3 all to the power of 4 over 4, right? We studied this before. Okay? So now, I equal, it will be this by this and this by this. Okay? It will be u by v, which is x times x plus 3 to the power of 4 over 4. Okay? Okay. Then minus, what is the rule? The rule says integration of u dv equal u v minus integration of v du. Okay, so it's going to be integration of x plus 3 to the power of 4 over 4 dx, right? Equal x bracket x plus 3 to the power of 4 over 4 minus 1 over 4. It will be x plus 3 to the power of 5. There is a problem in the program, I don't know why. Plus c. Okay, so if we want to take a common factor, it will be x plus 3 to the power of 4, right? Right. Bracket.
Yes.
Still have x over 4, x over 4 minus 1 over 1 over 4, 1 over 20, because 4 by 5, x plus 3, right? 1 over 20. Okay? Okay. Is this similar to this? Is this similar to it? Is it similar to it?
Only the first part.
Okay, listen to me. We can prove that this and this are equivalent. I can prove it. And let me just close this because there is a problem in writing. I don't know what is the problem. But you can prove that this easy. It's really easy. Don't worry. Okay? Don't worry. Don't forget that there is here an x, and here it will be it will be x over 20, okay, and it will be plus 3 over 20. How will you do that? I will show you, inshallah. Let me just try. X over 4 minus x over writing. There's a problem in writing. I don't know what's going on. Minus 3 over 20. Okay, this will be multiplied by 5 and this by 5. Okay. Unless we didn't do any mistake in at the beginning in here, تمام?